This is 1.5 solving equations. You do need your own piece of paper. We're going to be solving many types of equations, and let's start with quadratics. What we know about quadratics is that the standard form of the equation is going to be ax squared plus bx plus c, and that's going to be equal to 0. And if it's not equal to 0, then go ahead and set it and solve it to be equal to 0 so that it's easier to work with. Some different ways to solve quadratics is to factor it. We've been working with that for a while. The second way that you could solve a quadratic is by the quadratic formula. And if you don't have to solve the quadratic formula, and I just wanted to know the answers, whether it be, if I wanted to know if there was one answer, two answers, you could look at the discriminant. And that is this right here underneath the square root. That's called the discriminant. And what you could do is, this just helps you find solutions, okay? And what you could look at is the discriminant is if your b squared minus 4ac is greater than 0, then you're going to have two real answers, or two real solutions. If your b squared minus 4ac is less than 0, then you're still going to have two answers, but they're going to be imaginary, or they could be complex. And if your b squared minus 4ac is equal to 0, then you're going to have one real answer, but it could be a repeating answer. All right. Another way to solve a quadratic could be completing the square. We are not doing this today, but I wanted to go ahead and put it in the list. You're usually doing this when you're going from the standard form to the vertex form. Another way to solve quadratic is by graphing. All right, let's practice solving a quadratic. So the first thing that I would look at in order to solve this quadratic is, can I factor this? And I think this is nasty, so I'd say 2 times 1/2, or negative 1/2. Can I get a negative 1 out of that? And so I don't think I can factor this, so I'm going to go with the quadratic formula. You could go ahead and plug these in as your A, your B, and your C, but I'm going to multiply this whole thing by 2 to make it a little bit easier. So this is going to be a 4x squared minus a 2x minus 1, and that's equal to 0. So this problem's a little bit easier. So now I've got my A value, my B, and my C, and I can plug it into my quadratic formula, and it's a whole lot easier. So remember, this is x equals negative b, so this would be come a positive 2 plus or minus the square root of negative b. Oh, or I wrote that. So negative 2 squared minus 4 times 4 times negative 1, and that's all over 2 times a. And I'm not using my calculator, so let's simplify. So this is going to be 2 plus or minus, go ahead and say this is going to be 20 over 8. And let's just keep going. That simplifies. 2 plus or minus, how about 2 square roots of 5? And I'm going to break this up. So this is 2 over 8 plus or minus 2 square roots of 5 over 8. And I know my 2 8s can simplify. So how about a final answer of 1/4 plus or minus square roots of 5 over 4. And that should be a final answer for that quadratic. Okay, let's try a rational equation. Now I know a lot of you look at this and you try to go ahead and find a common denominator on this left side, and you're working with fractions the whole time. I don't like to work with fractions, so I get rid of them. And I get rid of them by multiplying by the common denominator. And that common denominator is these two binomials on the bottom. So I'm going to multiply by 2x plus 7 and x plus 3. And I'm going to do that on both sides. And I'm going to do that so that I can get rid of this fraction. If I multiply this first fraction by both of these numbers, I'm going to be left with an x and an x plus 3, because my 2x plus 7 cancels. Minus, okay, this minus is going to go to both of these. My x plus 3's cancel, so I'm going to have an x plus 1 and a 2x plus 7. Then my 1, nothing cancels over here, so it looks like I'm just going to have this whole mess here. So 2x plus 7 and an x plus 3. Now I have no fraction whatsoever. So now I can just distribute and start seeing what I get here. So this gives me an x squared plus a 3x. I'm going to distribute this inside first and then get my negative. So this gives me a 2x squared and then a 7x plus 7 plus 2x. This gives me a 2x squared plus 7x plus 6x plus 21. Now I need to distribute this negative in. So x squared plus 3x minus 2x squared minus 7x minus 7 minus 2x. And I still have the right side. Let's see if I can simplify some of this. 13 and 21. All right, anything cancel out here, but I can simplify. So I get a negative x squared. And this and this and this, it gives me a negative 9 and 3, so that's a negative 6x. And then a negative 7. Perfect. Still not working with fractions, which makes me happy. Okay, so let's get everything on one side. If I move everything over here, it's going to be positive. So I'm thinking this is the 0 side. Moving it over here, this gives me a 3x squared. Moving the 6 over here, that's going to be 19. Moving the 7 over here, that gives me a 28. All right. So all of that mess is a whole lot easier. Okay, from here you're going to have to factor. So I would say this is going to be the hardest of all the factorings. You multiply the first times the last, so 3 times 28, that gives me an 84. You need to find factors of 84 that add to give you 19. Well, I know I've got 2 and 24. I've got 4 and 21. 5 doesn't go. 6, 7 and 12. Oh, looks like I found it. These two add to give you 19. Now that I've found my factors, remember you plug back in, so that gives me 0 equals, so that's 3x squared. I'm plugging these back in. Doesn't matter the order. So that's going to give me 7x plus 12x plus 28. Now you see what you can take out of the first one, and I can only take out an x value. That leaves me with 3x plus 7. I can take out a 4 out of my next group. That leaves me with 3x plus 7. So these are the same, so that's one answer. So that's 3x plus 7 is one answer, and my next one is x plus 4. Go ahead and set each of them equal to 0. So 3x plus 7 and x plus 4, and solve. So this one's going to be x equals negative 7/3, and that would be an answer. And x equals negative 4, and that would be an answer. Now, one thing that I would say on this is to make sure, that's supposed to be a check, is to check your answers. This is going to be one special thing. Check answers. Now, why are we going to have to check our answers here? I have a negative 7/3. I'm going to plug it back in up here. If I plug in a negative 7/3 into this denominator, is there any reason I would get a 0? Zeros are not possible in denominators, and there's no way I'd get a 0. Would I get a negative 7/3? Would I get a 0 here? And I wouldn't. So I need to check my negative 4. If you plug in a negative 4 here, would I get a 0? And I'm okay. If I plug in a negative 4 here, would I get a 0? So I'm okay for both of my answers. So both of these answers are okay. So both of these are okay. So check answers, meaning check for what's called extraneous answers. Meaning answers that really don't work. And we just check those. Okay. Extraneous solutions would be false positives, meaning if I found these and they really didn't work. All right, let's try an absolute value. Absolute value, this is your problem. If this problem were set equal to a -1, you could go ahead and say no solution, because remember, absolute values are equal to positive answers. From here, I'm going to set up two answers, or two possible solutions that I'm going to solve. I'm going to set up 3x plus 5 is equal to a +1, and I'm going to say 3x plus 5 is equal to a -1. Because I know if I take the absolute value of a +1, I get 1. Absolute value of a -1 is also 1. So now you just need to solve these. So x is equal to -4/3 here. And over here, x is equal to -2. And again, check for extraneous answers. Or solutions. So plug in a -4/3 up here, a -4/3 times 3 plus 5, and you take the absolute value. This one works. If I plug in a -2, that gives me -6 plus 5, absolute value. This one also works. These are okay. How about we get rid of this 1 first? So this would be the square root of 5 minus x, and that would be x minus 3. Now let's go ahead and square it to get rid of that square root. So this would be 5 minus x. Now this one right here, remember this square means to double distribute. So I'm going to say x minus 3, and double distribute. Okay? So this is going to be x squared minus 6x, and this is going to be plus 9. Since I have a quadratic, how about we move everything to one side? So I move everything over here. So this is going to be x equals, or 0 equals. And the only reason I'm moving it to the right is so that everything's positive. So this is going to be x squared minus 5x, and this is going to be plus 4. And it looks like I can go ahead and factor this really easy. This is going to be x minus 1 and x minus 4. Set each thing equal to 0 and solve. That's going to be a 1. And x minus 4 equals 0. That's going to be just 4. Okay, again, check for extraneous answers. I can't stress that enough. If I plug in a 1, 5 minus 1 is 4. Take the square root, that's 2 plus 1. That would be 3. So let's write that down, 3. 1 minus 2, that's -1. This one does not work. That's not equivalent. So this would be an extraneous solution, which is a false positive. Okay, let's try this. 5 minus 4 is 1. Square root is 1 plus 1, that's 2. 4 minus 2 is 2. So this one works. So this is the only real solution. Okay? Literal equations basically means that you just have a ton of letters, which we do. Okay, how about on this one, we solve for x. Okay, the easiest way is to maybe make this as a proportion, or you could just multiply by that by the denominator. So if you multiply, this is going to be ax minus m is equal to 2 times this quantity is cx minus d. I have an x on both sides. How about we go ahead and distribute this? So this is ax minus m is equal to 2cx minus 2d. And then I can go ahead and get my x's on the same side. So I'm going to subtract the 2 over here so that I have ax minus 2cx. Moving the m to the right side, I have m minus 2d. Now this is where some people mess up here. I need the x alone, so I'm going to factor it out. That gives me a minus 2c. I have m minus 2d on the right side. Now I need to divide. So that's x equals m minus 2d over a minus 2c. And that would be the answer. But I do have a question. So are these two equivalent? And the answer would be yes. And cancel those out. Okay, this is it.